Uh, Thank you, Paul, and thank you everyone for joining this webinar. And today I'll be talking on actionable climate information for the Global South, introducing the South Asian regional climate information framework that has been recently developed. Particularly, I'll outline the how we can improve the regional climate information, reliability of regional climate information by regionally customizing a climate model. So I'm Pankaj Upadhyaya, a project scientist at IIT Delhi. We also have Saroj Kanta Mishra, who is the PI of the project, and also Devi Prasad Bhaiya, who is also a key architect in developing this framework. This framework is developed at DST Center of Excellence for Climate Information at IIT Delhi. Uh, I'll briefly talk about the context and background behind the development of this framework. So this framework was built upon the a national effort over the last past decade that started over a decade ago, and that underscored the uh, need for strengthening the regional climate modeling in India, and thereby making use of this climate information, reliable climate information for policy making. So our SARCI framework is an output of this national effort. Uh, with this context, let me start with the problem that we are addressing while while we have behind developing the SARCI framework. So one of our past research that was published in Nature Climate Change showed that the climate projections over South Asia over across 6 generations of IPCC assessments were highly inconsistent and at times self-contradictory. What that means is over the same region across the generations of IPCC assessments, the precipitation projections were at times inconsistent as well as at times self-contradictory as well. So that is a challenge for long-term uh, policy making, and it appears to be a bottleneck for a region, vulnerable region like South Asia, which is strongly dependent on climate-intensive sectors for its economy and for other sectoral planning. Uh, so these unreliable projections and inconsistent climate projections uh, implies paralyzed decision making, and therefore we need to address this inconsistency and unreliability in climate projections. So what we uh, uh, what we have in our hand is there are some long-term solutions, including development of K-scale modeling, AI integrated modeling. However, although these solutions seem to be promising, but they are at the same time resource intensive and also uh, presently emerging as a solutions. So it will take certain amount of time to these solutions to be ready. And as an interim and intermediate solutions, what we have in our hand are the use of large ensemble simulations and some statistical techniques, such as emergent constraint that Ray has presented in his presentation, and also we can strengthen our adaptation measures by particularly targeting the vulnerable communities and regions. One such intermediate solution is, however, is region-specific modeling that SARCI is an example. So I will talk about this SARCI framework in details in the following slides. So SARCI framework is an systematic approach in increasing the reliability of climate information. So this piece of work was published in BAMS recently. What SARCI exactly means is illustrated in this figure. So the SARCI framework, it starts with model selections, what we called as base model. And the base model is selected based on accuracy and efficiency. and also the scalability. And once we select this base model is analyzed for its performance and the biases or the sources of error in simulating the climate, regional climate in this base model is identified. Once we identify these sources of biases, these are particularly addressed by targeted model customizations, and these model customizations are further supplemented by model tuning and optimization, utilizing the high resolution and high quality data, regional data over the region. And once this model is customized, this model is verified and validated and is used for further future projections. And then for future projections, as we all know, the lower boundary conditions are very important aspects. So these lower boundary conditions are again further improved using some sophisticated techniques. And once this customized model forced with these improved boundary conditions, the cursor model output is finally downscaled and bias corrected and downscaled to get high resolution regional climate data, and which can be useful for policy making. So this is the SARCI framework all about, and this particular framework, in contrast to other resource intensive and computationally expensive approaches, is cost effective. At the same time, it is transferable, easily transferable, and also it is developed utilizing the local regional talent uh, that contributes to the regional capacity building in climate modeling. So here for our SASI framework, we consider NCAR CSM CAM as our best model, particularly for its demonstrated performance in simulating the South Asian regional climate. In next couple of slides, I will quickly explain the key components of the SASI framework. I will begin with the model customization. For model customization, uh, we mainly focus on the convection and land atmosphere interaction part. Many research, process studies, and research highlights that the errors in regional climate simulations over South Asia are originating from the atmospheric component of the model. So here we address these errors in atmospheric component by introducing uh, customizations and modifications in the deep convective parameterization as well as in the land air turbulent flux. In deep convective parameterization, we introduce a dynamic convective adjustment time scale in place of constant convective adjustment time scale that was present in the base model. We also introduce a stochastic entrainment rate in the base model in the SASI framework. Along with this, we also use South Asia specific similarity functions in land air turbulent fluxes that are also calibrated and optimized using the local quality observational data. So after these model customizations, the model is able to address some of the systematic biases that was present in the base model. Further, this model customization is supplemented by model tuning and optimization. As you all know, models contain several ad hoc and unobservable model parameters that are required to be tuned for a region. And then we use manual and semi-automatic tuning approaches to tune these models for South Asian region. We also keep in mind that while tuning these models, the global performance of the models are not compromised. So we use this model tuning for our SASI framework, and then after this customized and optimized model framework, we use this customized modeling framework for future projections. And when it comes to future projections, as you all know, the lower boundary conditions are one of the key aspects, and we construct and improve lower boundary conditions using skill-based CMIP models as well as observations. From CMIP models, we take the long-term changes and the trends, whereas the mean and the low frequency variability is derived from the observations. So this ensures that the errors in the lower boundary conditions are reduced, at the same time preserving the low frequency variability. Finally, the raw cursor output from this customized model forced with improved boundary conditions is bias corrected and downscale using a different module of the framework, where we use quantile delta mapping for the bias correction, and we use statistical downscaling for downscaling the cursor model data to high resolution data so that it can be useful for the regional scale planning. Now we evaluate the performance of this SARCI framework. To do that, here I have shown the performance of SARCI framework in simulating the precipitation as well as near surface temperature over South Asian region. As you can see, there is considerable improvement in SARCI framework compared to base model. For precipitation, it is almost 30% improvement in this SARCI framework. Whereas for temperature, there are substantial improvement, particularly in alleviating these cold biases over southern part of the South Asian region. At the same time, when we quantify this performance and compare that with the available CMIP models on the right, as you can see, for precipitation and for temperature as well, this SARCI framework outperforms many of these, a large fraction of these CMIP models, and it also performs better than the multimodal mean in many aspects. When it comes to SARCI's performance in simulating the annual cycle, um, since that the South Asian climate has a strong seasonality, particularly the precipitation. So this aspect of climate simulation is very important. As you can see, the SARCI framework can significantly improve the performance in simulating the annual cycle as well. It represents the seasonal cycle more accurately than the base model. Similarly, the SARCI framework also improves the uh, precipitation frequency of the over the South Asian region. So this overall contributes to the overall improvements of SARCI in simulating the South Asian climate. When it comes to improving the simulating the monsoon circulation over South Asian region, the SARCI again improves the both the lower level as well as the upper level circulation. For the lower level circulation, SARCI improves the strength of jet that particularly penetrates more into the South Asian land and also over the Bay of Bengal compared to the base model. At the same time, it also improves the uh, core of the jet when it comes to tropical easterly jet. That is one of the key features in South Asian climate, particularly during boreal summer. It also improves the representation of convectively coupled equatorial waves as shown on the right. So overall, this improved monsoon circulation and equatorial wave dynamics drive more realistic South Asian climate simulations by the SARCI framework. Finally, with this all customizations and all other components in place, we use this SARCI framework to project the future project the South Asian climate future of South Asian climate. We here like we saw the future projections for precipitation as well as for the near surface temperature, both for the mid future and for the long term future. As you and then I contrast these future projections from between the coarser raw output and the bias corrected downscale output. As you can see, the downscale bias corrected downscale output from SARCI produces much finer details, and also it shows lesser warming than the raw like without bias corrected and downscale output. And also the precipitation changes from the Downskilled and bias-corrected SARCI output shows diverse changes across the region. It also varies across the time as the precipitation that was mostly decreasing over the central and many parts of the South Asian region was like when it comes to the uh, long-term projections, it shows some different patterns as the precipitation increases over the southern regions of the India as well as over the eastern part of the South Asian region. So there are these nuances and details in regional climate projections are very useful when it comes to regional scale planning, and also the projections from these SARCI framework is different from what is usually projected using the CMIP multimodal mean. CMIP multimodal mean usually projects an overall increase of precipitation over South Asian region. However, our SARCI framework shows quite a different story with a diverse set of the diverse precipitation changes across the region. Uh, Finally, summarizing the accomplishments from this development of SARCI framework, the impacts in developing the SARCI framework extends beyond just reliable simulating the reliable climate information for the region. It also strengthens the regional capacity building it helps in creating skilled workforce and climate professionals that are required for sustained climate services for the region. The SARCI framework also shows that it's a framework that can be adapted for different needs depending on the scientific and policy needs. And also the SARCI framework is uh, not only relevant for the South Asian region, it is an example for other regions in global South that are also facing the similar kind of challenges, particularly in terms of resource constraints. And then these kind of efforts, the SARCI framework can be easily transferable and adaptable to other regions as well. Having said that, SARCI framework is not a complete solution, and since the performance is relative and some biases still persist, and this leaves the scope for further improvement in this framework. So we acknowledge our funding agency as well as the collaborators, numerous students, researchers, technical staff, visitors in developing this SARCI framework over the years. We also acknowledge National Science Foundation and NCAR for maintaining CSM as an open scientific resource that forms our backbone of the framework. And also we appreciate technical guidance received from NCAR scientists during model customization. Thank you.
Thank you, Pankaj. That was very interesting. I don't know, has anybody got I don't see any hands up, but if you've got a question, put your hand up. Otherwise, I had a quick question myself. What you've demonstrated there, I like this idea that maybe this could be transferable to other regions. One thing I was going to ask is this now being used, this SARCI framework being used operationally for policy decisions in India now for preparing for mitigation and adaptation in India?
So this particular framework is just ready, and it has been recently developed, and it is ready for sectoral applications. So um, we can easily use it for policy planning, particularly in India, depending on the needs. So yes, it is ready, but yes, it has to be utilized, and it has to be there in the market for ground policy making.
Yeah. Okay. Thank you very much.